And the next thing I want to do is I want to roll a video from the Spatial Audio team outlining some of the cool new features in WWWOE 21.1, and we're going to come back after that video and get some more detail on these features from the designers at Audiokinetic, the developers who have worked to create these features for you in WWWOE 21.1.
Rooms, portals, late reverb, and geometry have all been fully componentized such that audio environments can be built in a modular fashion and reused throughout the level. In this example, I am editing the blueprint for a building asset. I first add a box collision component and line it up with the bottom room of the building. I then attach an AK room component, AK geometry component, and AK late reverb component. I then add another box collision component and line it up with the entrance doorway. To this box component, I attach an AK portal component. With the blueprint structure set up, I can now save and compile and instantiate multiple instances in my level. Notice the red portal visualization, indicating that the portal placement is invalid. For aligning rooms and portals, a new Visualize Rooms and Portals option has been added to the integration settings, which can be used to visualize all of the rooms and portals in the level and their connections. Enabling this, I see that both front and back rooms of the portals are connected to the outside room, because it has a higher priority than my AK room component in the blueprint. I open the blueprint to update the priority of the AK room component. Notice that the Visualize Rooms and Portals option applies to the blueprint viewport as well as the level viewport. Going back to the level, the portals are now shown as valid. When working with existing level geometry, to which you want to add rooms, portals, reverbs, and acoustic geometry, the spatial audio volume and acoustic portal actors can be used. For fitting spatial audio volumes and acoustic portals to existing geometry, a new Fit to Geometry feature has been added. When Fit to Geometry is enabled, simply position your volume close to the geometry and it will automatically snap into place. As you move the volume, the calculated fit is highlighted in yellow. Releasing the mouse button will snap the volume to this new fit. The feature supports axis-aligned boxes, oriented boxes, and convex polyhedrons. It is also possible to reduce the search space within which the geometry fit is estimated. Here I am fitting a spatial audio volume to partially open geometry, so I reduce the search space to avoid distant geometry being used in the fit. In this example, I add an acoustic portal actor and use the Fit to Geometry feature to align it with the doorway of the building. Again, I need to update the priority value of the room component in the spatial audio volume such that it takes precedence over the outside room. The late reverb component has a new auto-assign aux bus feature. This allows the reverb component to automatically be assigned an aux bus determined by the size and shape of its primitive parent. In this example, the late reverb component is attached to a box collision component. Scaling the primitive parent automatically updates the aux bus assigned to the late reverb component. This means that with spatial audio volumes, when using Fit to Geometry, the reverb aux bus is automatically updated as the volume is fit to different environments. The aux bus assignment is controlled via the aux bus assignment map in the integration settings. The reverb decay value is estimated from the size and shape of the volume, and this is used to determine the appropriate aux bus. As well as decay, the late reverb component can estimate the time to first reflection, or pre-delay, value, as well as the high frequency damping value, using an AK geometry component's associated acoustic textures. These values can be used to dynamically drive a reverb effect in WWWOE via the global reverb RTPCs in the integration settings. Here, I add 3 new RTPCs to my WISE project, and then assign them in the integration settings in Unreal. I then hook up the RTPCs to a reverb effect. Now I can use the same aux bus for multiple different environments in my level, and drive the reverb parameters via the global reverb RTPCs.
Hello! 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 Hello!
When working with custom blueprints, the HF damping value is calculated using the AK geometry component. In this example, I have an AK geometry component and a late reverb component attached to a static mesh. The mesh is hidden and is only used to provide material slots for acoustic textures. It contains material slots for the walls, ceiling, and floor, and the AK geometry component assigns corresponding acoustic textures for each of these materials. The late reverb component uses an aux bus that has the global reverb RTPCs mapped to the reverb effect parameters. When the blueprint is instantiated in the level, the HF damping value is calculated using the acoustic textures assigned to the AK geometry component. When these textures are changed, the HF damping value is updated. Here I add 2 instances of the blueprint. I increase their size to accentuate the reverb and change the acoustic textures assigned to their geometry components in order to demonstrate how this affects the HF damping parameter on the reverb effect. Note that both of these reverb environments are using the same aux bus. It is also possible to attach an AK geometry component to a simple collision component, such as a box. In this case, there is just one acoustic texture applied to each surface. Acoustic textures can also be used with the spatial audio volume actors placed in the level. Acoustic texture assignment in the spatial audio volume has been simplified. Textures can now be edited directly on the object using the Edit Surfaces button. And multiple textures can be edited at once. In this example, I duplicate some existing geometry, as well as the spatial audio volume for that geometry. Fitting the duplicated spatial audio volume over the new geometry, I then change the acoustic texture applied to all of the surfaces in order to demonstrate the effect on the reverb.
What an incredible rundown of spatial audio goodness. Joining me today, I've got Sean Soraghan and Nate Harris. Welcome to the live stream, folks. How are you doing?
Good, thanks. Nate, I think you need to unmute in Teams.
Yep, if I didn't join muted, I would have been breaking tradition, so, you know.
Thank you for acknowledging that historic precedent that we've set here. It's great to have you today. Thanks so much, and thanks for your time to talk more about all the cool features of spatial audio in WISE 21.1. I'm going to hand it off to you for a presentation, and you're going to start running us through some of the cool things that are coming. Do you want to talk a bit about that while you're getting your screen shared over in Teams?
Sure. So, basically, I mean, you guys just saw that awesome video, and what I'm going to do is show you how you can fit geometry to your world in Unreal in real time, sort of fumble through the placement of these actors, and yeah, we'll see how it goes.
Great. I'll let you take it away. Thanks so much. Roll.
All right, so I've just got a little demo map here, and right now there's no rooms and no portals at all in my world, and I'm going to show you how I can add them and quickly populate them. Like, a lot of the hesitation with using rooms and portals in WISE is just generally that people don't like authoring them. So we have put some steps towards just taking the pain out of that process. So I'm going to drag a spatial audio volume into my world here. And then if we look in our details panel, I'll just filter by fit here. So we got this fit to geometry section. And now a little bit about how this works is if this is enabled, then it will fit as soon as you check the box or as soon as you move the actor. So I'm going to move it to an approximate location in my test level here. And then I'm going to tick my box, and then boom, it will automatically expand to the region that sort of surrounds it. It works by basically shooting rays from the middle here to probe the static mesh geometry around it. So as a visualization, we have these little hit points, and that can sometimes guide your placement. So as I drag the spatial audio volume around with fit to geometry enabled, it's going to search for static meshes in the world. And what I can do to sort of speed up my authoring process is just hold Alt while I drag, and that's going to create a copy. So right away I've got two, and now I just drag them both there. So Alt drag, and it's going to fit to this other room. Now, as I explained, it fires rays from the middle here. So sometimes what's going to happen is you'll get one of these probes exiting through a window like this. And this is clearly not the fit I'm looking for. So I can use my little filter hit point slider here just to reduce the distance. So that's going to filter out the 95% shortest rays, if that makes any sense. So that can sometimes just be a quick way to get it to fit properly. So let's thing you might have in your world is also geometry that's not aligned to your axis. I'm sure that's quite common. And if we just use the default settings and we hit fit, we get a box that it is aligned to the axis of the world. So we can switch the shape over to oriented box, and now it's going to search for an orientation. Sometimes it's useful to have it try to find the orientation for you, but if you know that your geometry is aligned to the axis, it's best to just leave that as oriented. I just want to, I'm going to switch back to aligned here and show you how when we're outside and we don't have four walls, you can still use this to kind of fit between 2 or 3 walls, and it will attempt to automatically disable some of these surfaces. Now, obviously, this isn't a perfect box, so we're not going to get a perfect fit, but we might be able to tweak it a little bit by changing the filter points. And then if that's not working, to get the exact shape we want, hopefully it'll give you a good approximation, and we can edit the geometry manually after that. So those are spatial audio volumes. Now, what about portals? Well, we have a similar feature for portals. Works very much the same way. Enable it, and then once you drag your portal, it's going to search for openings in the world to snap to. Just going to make this a little thinner here, and we can see that this is, by again, drag, it will automatically search for these openings and snap right in. I'm just going to place a few more here just for fun, just to show you how quickly I can author these portals. Quite satisfying when it snaps right into place like that. Just a little detail here. What it's searching for is basically a door frame. So you need parallel surfaces on the top, bottom, and side to side. You're not going to be able to fit if, say you had no roof. It's not going to work. Most scenarios where you have a nice door frame, it's going to work. Now, I'm sure what you're saying, let's go back to spatial audio volumes. I'm sure what you're probably thinking is that my world is not full of box-shaped rooms, so how is this going to help me? Well, the good news is, as long as your shape is convex, we should be able to still find a fit. In this case, we have this room that's kind of a house-shaped room, and it actually works quite nicely. And then I can just do the usual Alt-Drag and fit some of these other oddly shaped rooms in my house here. If I just go back one step here, you'll notice that the roof is kind of a blue color, and we've got this sort of turquoise color on the bottom. I'll just drag it up so we can see here. I just disabled fit to geometry, so it's not going to try and fit in this empty space here. But what it's gone ahead and done is assigned drywall to this top section and tile to the bottom section, the floor here. And how it's determined that is it's probed the physical materials of the mesh. And in my project settings, I have those hooked up in my integration settings. So I have a map here between the physical materials and my acoustic textures. And as of 21.1, Wise automatically syncs these with the authoring tool. And if you have names that match up, then this map will automatically populate itself. So hopefully we've taken out some of the labor in assigning those acoustic textures as well. Yeah, so that's just kind of an overview of fitting rooms and portals to geometry. I'm really excited to talk to you guys and hear about how it's working in your levels, and if you're having any issues or if it's speeding up your workflow. But for now, we're going to hand things over to Sean, and he's going to talk about some of those other cool features that you saw in the video there.
Okay, sorry, I couldn't find the mute button, but we're good now. Okay, so
It's a running theme.
Yeah, so I'm going to bring up Wise so we're all set up. Okay, sorry about that delay. Just to show you what I'm showing here, tell you what I'm showing. I've got Wise on the right and Unreal on the left. I'll sort of minimize Wise for now. I'll come back to it later. So I'm showing the Wise Audio Lab, the main map in the Wise Audio Lab. And so Nate's just given an explanation, obviously, of spatial audio volumes and acoustic portal actors, which can be placed directly in the level. To begin with, I'm going to give you an overview of like a parallel workflow, which is when you want to create custom blueprint classes and add spatial audio features to those blueprint classes, which wasn't entirely possible before because they weren't completely componentized, but now we've either altered or created new components in Unreal for adding spatial audio features. So if we look at the some of the spatial audio volumes to begin with in this map, just as a comparison, I'll zoom in here. We have this building structure here, and we have various spatial audio volumes that represent the rooms within this building, and also we have similarly various portals that represent the doorways and windows and stuff. So to demonstrate this blueprint approach, I've created a new blueprint class, and I've just recreated that structure from the level, but in blueprint. And so I'll just show you, it uses like the same visual meshes as the one from the level, but I'll first of all hide these meshes so you can see like the innards of the blueprint. And inside, if you look at the middle floor here, I have 3 box collision components, which I'm using to, I'll just zoom in here. I'm using these box collision components to represent the rooms, just like the spatial audio volumes in the level. And each of these box collision components has an AK room component, an AK geometry component, and an AK late reverb component attached to it. What I'm doing here when I attach these reverb, geometry, and room components is I'm basically recreating the functionality of a spatial audio volume, but I'm doing it in Blueprint. So similarly, we have the portals, where we just have lots of box collision components and we've added portal components to them. So I'll just unhide these meshes. So with that all set up, the cool thing about this workflow is that I can now just spawn that in my level, move it around, like spawn multiple of them, and it's all set up and ready to go from my blueprint. So that's a brief overview of like the blueprint workflow, which is now possible with this latest release. So I'm going to use this blueprint instance that I've just spawned to sort of segue into the next section, which is going to be about reverb and reverb aux bus assignment and reverb parameter estimation. So if we look at this blueprint instance that I have, I'll zoom in again on the world outliner here. So this is the blueprint instance in my world. If I look at its details panel, I can inspect the component hierarchy for that instance, just like I was showing you in the blueprint before. So if I click this late reverb component and look down at its details panel, you can see that it's using this new feature, which is auto assign aux bus. And so right now it's being assigned house living room, and that's because I have set up decay keys in the aux bus assignment map according to the size of these rooms. So as I mentioned in the video, the auto aux bus assignment works by estimating the decay of the reverb in your reverb environment and assigning an aux bus, and you set up that decay to aux bus mapping in your Unreal settings. The decay values are like upper bounds, so here anything from 0 to 0.2 will give you house small room, anything from 0.2 to 0.3 will give you house medium room, and so on. So if I play and
hello, hello, hello.
Should hear subtle difference between the reverb up here and the reverb down here. So the difference might be a bit subtle. So if you'll indulge me, I'm just going to get a bit silly, and I'm going to take my reverb, my blueprint instance, and duplicate it, and bring it over here. Oh, actually, sorry, I've missed a step. So I've just explained auto aux bus assignment. I'm now going to go into reverb parameter estimation. So we saw that I set up the decay keys, and they automatically populated my reverb aux buses. But another thing we can do is we can use that decay value and directly map it to the reverb decay parameter instead of choosing an entire aux bus. And as well as that, we can also do the same thing for frequency dependent damping, or HF damping, and time to first reflection, or pre-delay. And that is controlled in the integration settings via the RTPCs here. So you can assign RTPCs from your WISE project to these global RTPCs in your Unreal settings. So I've done that. So I'm just going to bring in WISE to show you. So if I go to GameSyncs, I've got these 3 new RTPCs that I've created, and I've also created a new aux bus. A new aux bus with a simple room verb effect on it, but I've mapped the parameters of that room verb effect to these RTPCs are driving those parameters. So that's the WISE setup. Now if I go back to the Unreal settings here, I can map those RTPCs that I set up in WISE to these Unreal slots. So let's put, HF damping, decay is room decay, and time to first reflection is room pre-delay. So the last thing we have to do to use this feature is in our blueprint instance, we need to make sure that our reverb components are actually using this new dynamic room verb aux bus. So one way to do that would be to just select each reverb, uncheck auto assign, and choose dynamic room verb. But there's a kind of quicker way to do that using aux bus assignment again. So with the auto assignment map, anything above the highest decay value will be given the default reverb aux bus, and if there's no decay values, everything that uses auto-assign will be given the default one. So if we set that to dynamic room verb and go back to our blueprint instance, the late reverb components now all have the dynamic room verb assigned to them. So now with that set up, now I'm going to do the whole duplication thing. But before that, I'll just play and let you hear what it sounds like using this approach.
Hello!
So again, some subtle differences in the reverb between each room. The difference here is that they're all using the same aux bus, but the individual parameters are changing. And you can see that in Wise actually if you look at this box, when I move between rooms, there's a new decay time being assigned. So now is when I was going to say that might sound a bit subtle and it might not come across on the stream. So I'm going to duplicate this, bring it across here. I'll bring it all the way into the football pitch, soccer pitch, whatever you want to call it. I'll scale it up to a ridiculous size and bring it back a bit and just move it down so I can walk inside it. So I've duplicated this blueprint instance, increased its size and moved it over here. And the important thing here is that it's all of these rooms in this building and this building are all using the same aux bus. So now if I play and again start in the
Hello! Hello! Hello!
so that's the reverb of the first floor in that building. Now walking in here.
Hello!
You can hear that the reverb has been appropriately, the decay has been increased appropriately. So that's basically all the features I wanted to get across. There's one last thing I'll go through quickly, which is, so the auto-assign aux bus and reverb parameter estimation, I demonstrated them in the context of a blueprint class, but they can just as well be used in spatial audio volumes. So if I'll use the train station, one of the train station sort of rooms to demonstrate this. So here I have this sort of train station building, and it has the brick texture applied to all of the surfaces. So these acoustic textures up until now have just been used for Reflect, for controlling the parameters of the Reflect plugin. But now you can use these acoustic textures to actually change the HF damping, this value of a reverb effect. So I'm just going to move my player start somewhere close to that room. And I'll just make sure that so I'm just making sure that spatial audio volume is using the dynamic room verb, which it is. So now if I play, I've also added some drums using the amen break to demonstrate this. But I've just remembered that if I talk while I do this, you're not going to hear anything, so I'll just explain it first. I'm going to play a drum loop inside this big building, walk inside it, and then change the acoustic texture that's being applied to this spatial audio volume while it's playing to show you what that does to the HF damping. So I'll do that now. Music. If we change the acoustic texture to tile, so that's just how the acoustic textures can be used to change the HF damping. One last thing, you might see that the UI for assigning textures to a spatial audio volume has changed. So we used to have a big list of material of acoustic textures with numbers in the level, but now we actually have this enable edit surfaces button, which allows us to, if I just increase my speed, we can like choose individual faces and then change their acoustic texture. And yeah, we can do that for different different parameters like the transmission loss or the enable surface. So now I have like different surfaces on each face, or you can just override all of them at once. And that is the end of the demo. I hope I didn't overrun for too long, but I'm going to stop sharing now.
No, I mean, a fantastic overview of those features. And again, like just the creativity to arrive at this place with these workflow speed ups and again, seeing your process working between Unreal and Wise, you both really optimized those kind of workflows, and it's exciting. Like Nate mentioned, people getting their hands on this, working in these workflows. We're really excited to hear more about people and their use of these. So, thanks so much for those overviews. Nice work.